Well, welcome back to part two of chemistry and biology. This time I'm going to talk about molecular hybridization and chemical groups. So let's start off with molecular hybridization. So this actually has to do with polarity, which I explained last time. So specifically, it has to do with the molecular polarity. So last time I said that the geometry of the molecules will determine if it is a polar or nonpolar molecule. So how do we even know these geometries in the first place, right? This has to do with hybridization. So when we have two covalent molecules bonding together, or covalent atoms bonding together, um, if we have two atoms that bond together and they form a covalent bond, right? Then we can, combine more of these covalent bonds to form a molecule, and it's all bonded by covalent bonds. And that actually is not just some atoms having separate orbitals sharing electrons. What actually happens is each atom will dissolve its own orbitals. So like having like an octet, that doesn't exist anymore. What ends up happening is they the entire molecule gets its own orbital. And this is called molecular hybridization. All right, it's a hybridization of orbitals. You're combining the orbitals of the atoms into a completely different new orbital for the entire molecule. Okay, and this hybridization is super important because the most important kind of hybridization um, in biology is going to be sp3 hybridization. You don't have to know what this means, you don't really have to memorize that, but basically what it's saying is um, there's actually specific like geometries associated with each type of hybridization. And so carbon is sp3 because it has four valence electrons by default. So as you can see, it's kind of like S1P3, 1 plus 3 is 4, that's where that comes in. And so carbon will have, you can see like on its stick figure, if you add 4 hydrogens to carbon, you get methane. And, this four-sided, four-pronged molecule is no mistake. It actually doesn't look like this in real life. In real life, it looks like a tetrahedron. And while I can't really show that to you on a 2D video, I'll try my very best. And basically, what we'll have is carbon, right? We'll have something at the top connected to, let's just say, hydrogen again, right? But now it's going to kind of be like this. So it's like a tripod kind of. So let's say we have like imagine this is like a tripod with 3 legs, right? And then the 4th thing is up here. So as you can see, it kind of looks like this original one. But let's make this kind of like bent upwards a little bit to kind of show how it's tripody. Basically, this in 3D space is going to maximize the distance between each of the hydrogens because they repel each other. Why do they repel each other? Well, because they have electrons floating around them, and electrons repel. And so do the protons between each of these atoms. They also repel because opposites, or not opposites, the like repel, right? Same charge, they repel. Okay, so that pretty much explains why we see molecules with containing carbon might hybridize as sp3, and this is how they get their geometry. Um, Oxygen or water is a little bit more complicated. Um, I do believe it's somewhat out of the scope of this class. This is something you'd probably learn in AP chemistry instead, or general chemistry if you're in college. But 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 just remember that it's bent, and you'll be pretty okay. Um, so yeah, that's basically why we have all of these hybridizations. Why we have these different geometrical configurations. The next thing I want to talk about is chemical groups. So there are many different kinds of molecules in biology, and we want to start off with kind of like how they're pretty similar to each other, right? So the first important thing is just seeing what kind of basic chemical groups we have and how they can be added as like puzzle pieces to the larger puzzle. So the first group is what we call hydroxyl group. So we have an oxygen and a hydrogen. All right, and this little stick is kind of connected to another molecule. We don't know what it is. And over here, the oxygen has 2 electrons, one on each side, being connected as a line. So we have 4 left, and 2 go on top, 2 go on bottom. Okay, water is barely considered a hydroxyl. I wouldn't really worry about that. But pretty much an OH group is actually chemically basic, so it's like the opposite of acidic, right? And that's kind of out of the scope of this video. I can maybe talk about it later, but yeah. Okay, then what we have is something a little bit similar. I'm not going to erase this actually. We have what's called the carbonyl group. And the carbonyl group is where we have something over here. We don't know what it is, but it's connected. It's connected to a carbon within a double bond to an oxygen. And then this oxygen, it should still have 1, 2, 3, 4 valence electrons on its outside that are not being used in a bond. And yeah, it doesn't have anything else. It might have something else connected over here, but we'll go into that later. So that by itself is called a carbonyl group. However, if we decide to add, let me erase this first. Okay, if we decide that over here, instead of having an unknown molecule, we wanted to have a specific molecule, and this specific molecule is going to be a hydroxyl group. Sorry, we can't have double bonds here. Let's say this is we add a hydroxyl group to a carbonyl group. What ends up happening is this is called a carboxyl group. And this is actually kind of important because that's one of like the things that are present in each amino acids, and you'll get to amino acids later if you haven't already, but they're really important in biology. Okay, next is an amine group or an amino group. So I just kind of gave it away, but yeah. It's the other part of an amino acid group that remains the same for all amino acids. And so actually, an amino acid is going to be an amine group connected to something. I think it's a carbon. Yeah, I'm not sure. I'll just put a question mark here, and then a carboxyl group over here. And I'm just going to write OH over here like this, because technically, I mean, you can you're supposed to put a line here, but to be lazy, I can just put a is it hydroxyl? Hydroxyl group over here. And the reason why I'm stumbling with these group names is because we don't really use this in real chemistry. It's just what biologists use. So I don't really care about this, except you have to learn this. So good luck with that. But this basically forms, oops, this basically forms a amino acid. This is the general structure of it. It'll contain an amino terminal, a carboxyl terminal, and some other stuff attached to it. And the rest of the groups you can study by yourself, but they are not really related to amino acids. So they're kind of on their own, whereas these appear way more often. Even in like chemistry classes, we just don't refer to them as carboxyl or hydroxyl or whatever they're called. So I hope that was helpful. Um, and yeah, so that is pretty much all the chemistry you'll need to know for biology. However, I know that the book I'm referring to does include, some acid-base stuff. I wouldn't really worry about it. Just know, pH-wise, 1 to 7-ish is acidic at a temperature of 25 degrees Celsius, whereas 7 to 14 is basic. And I'm actually lying here. This is like really simple, really basic, not to make a pun or anything, but it's actually much more complicated than this. And I said at temperature of 25 degrees Celsius. It's just because pH is actually the neutral does change at each temperature, and plus they're negative pHs and pHs above 14. So yeah, so you don't really need to know that in biology. But you might want to know that pH buffers, which basically are chemical systems that maintain a steady-ish pH even with changes in concentration of each molecule. Those buffers are used in your body, and that's really important in biology because it will maintain that pH, right? Um, and so your bloodstream will use a buffer to keep the pH steady, and that allows your body to reach homeostasis in that case. Because if your body has a pH outside like a very small tolerable range, you could die. So yeah, it's really important that pH is maintained. So other than that, though, there's not really that much chemistry in biology. So good luck in your biology class. If there's anything else, I'll cover in video 3. If not, you won't see video 3. All right. Have a good day.